The power of calculus and linear algebra in cognitive science. Welcome to our video on the power of calculus and linear algebra in cognitive science. In the next few minutes, we'll explore why these mathematical tools are more than just numbers. They are key to understanding the brain, behavior, and beyond. Calculus helps us understand change. In cognitive science, this means modeling how neurons fire, how learning happens over time, or how memory decays. For example, researchers use derivatives to analyze brainwave signals and determine how they evolve in milliseconds. Calculus is also used in AI to train machine learning models using optimization techniques like gradient descent. Linear algebra is the language of data. It powers image recognition, brain scans, and even chatbots. Imagine trying to represent a brain scan. It's just a giant matrix of numbers. Vectors and matrices help us organize, transform, and analyze huge sets of data, which is essential in neuroscience, psychology, and artificial intelligence. In research, calculus and linear algebra often work together. For example, in a disease outbreak, calculus models infection growth over time. Meanwhile, linear algebra helps simulate the data of population movement or virus spread in a city. Together, they help health officials make better decisions, like when to implement lockdowns. These tools also help cognitive scientists understand the brain itself. Using fMRI data, we can model how different brain areas activate and interact. With linear algebra, we reduce complex signals using techniques like PCA principal component analysis. With calculus, we model learning processes and predict outcomes. Did you know, the way your Spotify or YouTube recommends songs uses linear algebra, it compares your behavior to thousands of others using vectors. And when your smartwatch tracks your sleep, calculus models your sleep stages through rate of change in movement and heartbeat. Math is watching over your mind and your playlist. Think this doesn't apply to you yet? Think again. If you're creating a survey for your final year project, you'll use linear algebra to analyze results. If you're building a cognitive model for class, you'll use calculus to predict how memory fades over time. Even basic psychology tests use data patterns, and those patterns? They're just matrices and graphs. Mastering these tools now makes everything easier later. Did you know that the origins of calculus date back to the 1600s? Developed independently by Isaac Newton and Gottfried Leibniz? Linear algebra, on the other hand, grew out of solving systems of equations, which was crucial for astronomy and physics. Today, these ancient tools are helping us understand consciousness and build intelligent machines. From telescopes to brain scanners, that's evolution. Calculus and linear algebra also play important roles in modern linguistics, especially in the fields of computational linguistics and natural language processing (NLP). Linear algebra is essential for representing linguistic elements in mathematical form, particularly through the use of vectors and matrices. For example, word embeddings, such as word2vec or glove, represent words as vectors in a high-dimensional space, allowing computers to understand and compare meanings based on vector similarity. Operations like matrix multiplication, dot products, and singular value decomposition (SVD) are used to process and analyze large corpora of text. Calculus also helps model how linguistic features change over time, such as in studies of language evolution or dialect shifts. Together, these mathematical tools enable deeper analysis, prediction, and simulation of language patterns, bridging the gap between human communication and computational understanding. Calculus and linear algebra aren't just math subjects, they are bridges to understanding thought, behavior, and intelligence. In cognitive science, they help us explore how we think, how machines learn, and how we can improve the world. By mastering them, we're not only solving equations, we're solving the future.